Physics Lab 3, and in this lab we observe a motion of a star orbiting a black hole and then use that motion data to predict the motion past. And these are all the relevant physics equations for this lab. And we modeled the data in VPython using it to extract data from a CSV file and then calculate all the forces. So delta V is equal to the V final minus V initial, which is based on the distance the star traveled between two time jumps, which is about 1 Earth day in seconds. And the P initial, the momentum, is the star's mass times its initial velocity. Finals minus is its mass times the final velocity. So which makes delta momentum, change in momentum, delta P, P final minus P initial. And then we use that to calculate the change in momentum, which is equal to delta P over delta T, which is equal to the net force. And then we multiply it by the vector P hat to calculate the magnitude of it. And then we set that equal to the net force in the parallel direction. And then the net force in the parallel direction plus the net force in the perpendicular direction is equal to the net force. And then we use that to calculate the star's velocity, or not the star's velocity, but the force acting on the star as it orbits the black hole. Is then modeled, this black arrow being the force in the parallel direction, which is small comparative to the force of gravity, the force in the which is all of the net force in the yellow arrow. The blue arrow is the force in the perpendicular direction. And then using the data we got out of that simulation, we can calculate the mass of a black hole using the equation Fnet equals G m1 m2 over r squared. But manipulating that, we get the mass of the black hole is equal to Fnet times r squared over G times the mass of the star, which comes out to about 2.67 times 10 to the 31st. And so if we were to imagine a black hole whose mass was, if the black hole we found was removed and a different one was placed at the same location and the motion of the star remained unchanged, it would literally be impossible to have a new black hole with different mass, because a black hole with different mass would exert a different gravitational pull on the star as it orbited it. And Fnet perpendicular, Fnet parallel, and Fnet are not different from change in momentum over time, perpendicular, parallel, and just change in momentum over change in time. Those are actually the same quantities because force is equal to a change in momentum over a change in time. And so because of that, it's just a different way of writing the exact same thing.